Just as we can change points back and forth between polar and rectangular form, we can change equations back and forth between polar and rectangular form. And we'll use the same conversions that we did for the points for the equations. So this will be x equals r cosine theta, and y equals r sine theta, and r equals square root of x squared plus y squared comes in handy too. Let's see, I have r equals -2 cosecant theta. Well, that's not that helpful because none of these conversions have a cosecant in them. So we're also going to use identities. I'm going to use the fact that the cosecant is the reciprocal of the sine and rewrite this -2 over sine theta. Now, all the algebra you know still applies, so I'm going to multiply both sides of my little equation here by the denominator, by sine theta. I have r sine theta equals -2. And now, well, r sine theta, we have a name for that. It's y. Why am I going to write r sine theta when I could write y? So I have y equals -2. There's my equation changed to rectangular form, and hopefully this is something that you recognize as the equation of a horizontal line. It was a horizontal line when it said r equals -2 cosecant theta also. We just don't necessarily recognize that form, and so we change it into a form that we can recognize more easily. Here's another one. I've r equals 2 cosine theta. If only there were an r right there, I would have 2r cosine theta, and I could call it x. But there isn't an r right there. So what are we going to do? We're going to multiply both sides of this equation by r so that there's an r in there. So now I have r squared equals 2r cosine theta. And r cosine theta, I can call that x. So this is 2x on the right. If I'm going to change the right-hand side to rectangular form, I have to also change the left-hand side to rectangular form. I can't have r's and x's playing together in the same equation. Kind of doesn't make sense. So r squared, well, I know r is the square root of x squared plus y squared. So r squared, I'll have x squared plus y squared without the square root. That's lovely, but it still doesn't quite look like anything that I recognize. I'm going to take this 2x and pull it over to the left, strategically leaving a space there. Now I have nothing on the right because I subtracted the 2x away. I'm going to complete the square here on the left. If I add one on the left, I had better also add one on the right. So now I have, if I factor, this is x minus 1 squared and equals 1. Hopefully you recognize that as the equation of a circle with center. Let's see, x is 1, y is 0. And with radius, well, r squared is 1. That means r not squared is also 1. So a circle with center 1, 0, and radius 1. There's 1, 0. Radius is 1. I'm going to carefully connect my dots so that it looks like a circle and, well, and not a diamond. Well, it doesn't look like a diamond. It doesn't look like a circle either. There, that's better. So a little circle on the x-axis.